moving on to section 5.1, and we're going to start talking about normal probabilities. And thankfully, Google Sheets has some really nice ways to calculate normal distributions. Let's start with talking about the difference between a normal distribution curve versus the standard normal distribution curve. Normal distribution curves are bell-shaped, they're symmetric. The area underneath them is 1 because it represents the entire population. They are centered on the mean. Their x values or the x-axis will be labeled with the x values of the data set. The problem with this is every single time you calculate try to do some calculations on a different population, you would have to create a new normal distribution curve and calculate the areas underneath that normal distribution curve. So to simplify this, we go ahead and convert all of those data values on the x-axis into z-scores. Now, if we remember back in an earlier chapter, we talked about z-score. Z-score is the number of standard deviations that fall between a data value and the mean. So it's counting how many standard deviations some data value is away from the mean. And the equation for that was, let's make this a little bigger, undo, do that. So our data value is z equals x minus the mean. That result then divided by standard deviation. Why this is giving me such a problem here. Let's just do that. Boom, fixed it. So now we can see the equation. Now, Google Sheets uses a formula called normal DIST, norm DIST, and we can utilize it for both our normal distribution curve when we're talking about x values, or the standard normal distribution curve when we're talking about z values. In either case, you're going to start off by typing equals norm DIST. Since right now in chapter 5.1, we're going to talk about the standard normal distribution curve, all of our calculations are going to be done using z-scores on the x-axis. So our inputs are going to be z, 0, 1, the word true. Z represents the z value that we're talking about. 0 is the mean or the center of our data set. 1 is the standard deviation of our data set. With the z-scores on the axis, we'll be counting by 1 standard deviation each time. And true is telling it to do a cumulative probability calculation, where it's going to do a sum of probabilities. It's important to note that normal DIST always calculates a cumulative area from negative infinity, that's way out on the left-hand side, to the x or z value that you choose. So it's always going to calculate the area on the left-hand side of your x or z value. So if you're looking to find that as an answer, you are talking about a question that uses the words less than or below a z value. You're simply going to input normal DIST, z, 0, 1, true. In the event that you wanted to find an area to the right of some z value, remember, the total area under the curve is 1. So if you want to find the area to the right, first find the area to the left, and then subtract that part that you don't want from the total, which is 1. So you would simply input 1 minus normal DIST, z, 0, 1, and the word true. Other question you could be asked, find the area between two z-scores. To do that, you would need to calculate 2 normal distribution areas, and then you would subtract the larger area minus the smaller area. So normal distribution, z2, your larger z-score, 0, 1, true, minus normal distribution, z1, the smaller z-score, 0, 1, true. So we're going to look at some examples here from the textbook, and these are on page 225, and they are even problems, so they're not problems that I had assigned to you. And we're going to go over some of them, but not all of them. So let's start with number 22 here. It says, Find the indicated area under the standard normal curve to the left of z equals 0.25. So we're going to want to input normal dist, comma, or 0.25, comma, 0, comma, 1, comma, true. So let's go ahead over here and input that. Equals norm dist, parenthesis, 0.25, comma, 0 for our mean, 1 for our standard deviation, and true to tell it to do a cumulative area. Bingo. 0.5987. That is the correct answer in the textbook for number 22. Jump down here to number 26. Now says find the area to the right of a z-score of negative 1.75. Area to the right. So we're still going to do a normal distribution. Negative, I have this written in here incorrect. Let me fix it. Negative 1.75, comma, 0, comma, 1, comma, true. And we're going to want to subtract that answer from 1. So we'll type that in. Equals 1 minus normal dist negative 1.75, comma, 0 for our mean, 1 for our standard deviation, true to tell it cumulative area, 0.9599 is the correct answer to number 26. We'll try another one here. We're going to do, again, area to the left of negative 3.08. This should give us a very small answer. So we're going to type in equals, again, to the left means just do the normal distribution. Negative 3.08, comma, 0 is our mean, 1 is our standard deviation, true, 0.0010 is the correct answer for number 30. Might as well do this number 32. Area to the right. Again, we're going to do 1 minus a normal distribution. Our z-score is 2.51, comma, 0, comma, 1. And the word true is what we would input. Come over here and try it. Equals 1 minus norm distribution 2.51, comma, 0, comma, 1, comma, true. 0.006. What number was that? Number 30? 1, comma, oh, number 32. 0.006 is the correct answer. Excuse me. And now we have this in-between question. We want to find the area in between z equals 0 and z equals 3.09. So if we do a normal distribution using the z-score of 0, that's going to give us the area to the left of 0. If we do a normal distribution with z equal 3.09, that's going to give us the cumulative area to the left of 3.09. Now what we want is the area that's in between the two. So essentially what we're doing is we're finding a bigger area with this one and the smaller area that we don't want, the part we don't want with this one, and we're going to subtract those two values. Now I know the answer to this is 0.5 because we're symmetric about the mean, but we're going to just go ahead and input it the way it would work. Norm distribution 3.09, comma, 0, comma, 1, comma, true, minus normal distribution 0, comma, 0, comma, 1, comma, true. I apologize, it went off the screen there a little bit. And we're going to hit enter. And we are going to get an answer of 0.4990. That is the correct answer in the textbook. So that wasn't too difficult. All we had to do was find the area to the left of our larger one and subtract the area to the left of our smaller one. Really, 36 and 38 are just like that. Let's take a look down here at number 40. 40 is a little different. It says find the area to the left of negative 1.96 and to the right of 1.96. So we know this area to the left is very easy. We could do normal distribution, negative 1.96 comma 0, comma 1, comma 2. That's going to give us the area to the left. We could very easily do a 1 minus normal distribution, 1.96, comma 0, comma 1, comma true. And that would give us the area to the right of 1.96. But here's the thing. Our distribution is symmetric. So whatever the area to the left of negative 1.96 is, that's going to be equivalent to the area to the right of 1.96 because of the symmetry of the bell curve. So because these z-values are the same distance away from the mean, this one in a negative direction, this one in the positive direction, the area that's outside of those z-scores is going to be equivalent. So what we really can do here is we can just do equals normal distribution. We're going to do the negative 1.96, 0, comma 1, comma true. I'm going to close that, and I'm just going to multiply that times 2. I'm just going to double that value. And we got an answer of 0.05, and that is the correct answer. So normal distribution, pretty easy to use, very easy inputs. Your z-score, 0 for your mean, 1 for your standard deviation, the word true to tell it to do a cumulative area. Keep in mind the rules, and you can see these rules are also in your chart in your textbook. That is on page 221. Areas to the left, you're just finding the normal distribution answer. Areas to the right, you're doing 1 minus the normal distribution answer. And areas in between two z-scores, you're going to find 2 normal distribution answers and subtract them. The textbook utilizes a table in the back of the book to do this. You could do it on a TI-84 if you want to look up those directions. There's plenty of videos on YouTube on how to do that. There's also, I've linked to another kind of app that kind of lets you just drag your Z back and forth on your x-axis, and it'll give you the answer. So I have that link for you as well. So I hope this works. If you have any questions, again, reach out on the Q&A doc or send me an email. Thanks a lot. Have a good night.